Good morning, everyone. My name is Alessandro. I'm joined alongside Brett and Emmanuel. We're Team Eternals. Today, we're going to be going over our final project, which is about data-driven location targeting for used car sales and trying to identify high potential zip codes in the South Carolina area. I will go ahead and turn it over to Emmanuel, who will start us off discussing the objective of the project.
Thank you, Alessandro. The objective of this project is to develop a tool that helps a used car dealership identify zip code areas with high concentration of potential buyers, specifically individuals between the ages of 18 and 44 with household income ranging from $50 to $100,000, including college students. The business challenge addressed in this um, project is how to most effectively target outreach and advertising towards individuals who are most likely to need reliable, affordable transportation. By leveraging demographic data such as age distribution, income levels, and population density, this tool gives dealerships a competitive edge by enabling strategic location-based decision-making. It reduces wasteful spending and improves the chances of reaching customers more likely to make a purchase. Our problem statement. Used car dealerships in the Charleston, South Carolina area struggle to identify which zip codes contain their ideal customer base, people aged 25 to 44 with household incomes between 50 and 100,000. This makes it hard to target marketing effectively, often resulting in wasted advertising dollars on low potential areas, missed opportunities to connect with likely buyers, low conversion rate despite high marketing spend. The goal of the project to develop a data-driven tool using US Census data that identifies high potential zip codes for targeted outreach, helping dealerships focus their advertising and promotions, increase lead quality and conversions, optimize inventory and location strategy.
Yep. Thank you, Emmanuel. So we started this project by installing the Python packages as well as libraries that are necessary for the environment. Um, then we loaded API key information as well as census data using the source U.S. Census Bureau American Community Survey ACS 5-year estimates. We used multiple variables, three key metrics of median age, total population, median household income within the Charleston region. And then this helped us create a table. And then we sorted this table, into using the describe function, we sorted it into a bar chart um, with the top zip codes by median income and the top counties around the Charleston area. So some key insights on this is that Mount Pleasant North and Daniel Island stand out the most. These areas have the highest median incomes, well above 100,000, and they are likely to contain more financially stable residents who can afford certified, used, or premium vehicles. Mount Pleasant South and James Island also performed very strongly. These zip codes follow closely behind the top two, suggesting strong potential for dealerships who are marketing mid-range vehicles. This would be good for them to market there. Then a gradual decline in median income from Outer West Ashley to Goose Creek. These are all in roughly the $80,000 median income range. So dealerships should probably prioritize more budget-friendly vehicles in the $15,000 to $20,000 range and offer financing options. So we classified these um, counties into three different tiers. Tier one being the top counties, Mount Ple or the top zip codes, Mount Pleasant, North and South, Daniel Island. This would be best for premium vehicles, like I stated earlier, for dealerships to target their marketing ad spend. Tier two would be James Island, Outer West Ashley, and the Charleston Peninsula. This would be good for mid-grade vehicles to be targeted. And then tier three with Somerville, Goose Creek, and Monarch's Corner. this would be best for budget-friendly vehicles. Then we created an MLM, machine learning model, that predicts median income using a simple linear regression model using two metrics, total population and median age. To do this, we installed some libraries that we needed. Then we prepared and split the data and then trained a linear regression model and then made predictions to evaluate it. And below you will see the model summary and results.
Thank you, Brett. So let's start with our first attempt at prediction, which using the linear regression. So we regress median household income on two readily available demographics, which were total population and median age in each zip code. So the intercepts would be minus 15,000. So you could think of that as the baseline when both predicators are at zero. For every extra resident, income nudges up by about 0.0027. So population alone is not a very strong signal. However, every additional year in that median age is going to correlate with 2,638 more in median income. It sounds encouraging until we look at the performance metrics. The model's mean squared error is 564 million. R squared is minus 2.20, which that tells us that the model explains less variance than just simply predicting the overall average for every zip code. So where do we go from here? We'd like to bring in some other predictors like education attainment, car ownership rates, employment sectors. Um, Dealerships know, or variables that other dealerships know influence purchasing power. First, First pass, sorry, however, shows how a predictive layer can be wired into the business toolkit. So we can go down a tiny bit. Classification. So we labeled each zip as high income if median income is 75,000 or above. Using population and age again, we trained a logistic regression and held out 20% of the zips being for testing. If you want to scroll a little bit down again, thank you. Over 33% accuracy overall. So precision on the high income class is also 33%, but recall is 100, which means that we caught every genuinely high income zip code at the cost of flagging to lower income areas as well. The confusion matrix at the right illustrates that trade-off. So zero true lows were correctly classified. Um, what the struggle was for. So small sample size and a severe class imbalance. Only one zip in the test set truly met the $75,000 threshold. With more features, a larger regional data set, and standard resampling techniques, we expect recall precision to converge as well. So conclusions, the key takeaways. Despite modest metrics, the ex exercise pinpoints where analytics are definitely going to help or could help a sales strategy. EA isolated five zip codes, being the Mount Pleasant North and South areas, Daniel Island, West Ashley, both halves of the Somerville, that already line up with the dealer's target segment in that age range from 25 to 44 years old. The earnings range 50 to 100,000. Also, even basic models reveal what extra data would sharpen predictions. So we have a clear roadmap now of, augmented demographics or train comparing algorithms side by side. So the insights definitely are informative of where a spending could be focused and richer models for following day to turn those insights into a competitive edge.
So our recommendations, as you all know, it is extremely important for businesses to convert every link to potential purchases. So we recommend target marketing efforts in high potential zip codes such as Mount Pleasant and Somerville to maximize return on advertising investment. Secondly, we recommend that you develop regional strategies by customizing inventory based on local demographics, that is, the appropriate car for the appropriate area. So in younger areas with the median age under 35, focus on reliable, fuel-efficient vehicles. In higher income areas, consider offering certified pre-owned or premium used cars. Thirdly, refine the model by incorporating additional features, educational level, car ownership rates, commute time or public transit access, number of college students. And if these things are added to the model, we believe it will give a better result. Expand to other regions. We believe this tool is scalable to other industries and to other regions. So the current tool is built to be reusable. Just change the zip code, filter to target any US region, making it adaptable for franchises or multi-city operations. Combined with real dealership data, sales per zip code, customer survey data. We need to point out that the data we used for this model was solely from the US Census database. We believe that it will give better results, and for stronger predictive modeling and inventory planning, we recommend that you use actual dealership data. Thank you. I'll pass it on to Alessandro.
Thank you, Emmanuel. Thank you everyone for watching. That is our presentation and our final project. Hopefully these insights that we're able to cover were valuable, and we appreciate all the time. Thank you very much.